Good morning, YouTube. How's everybody out there doing? My name is Greg. I'm from GregsTutoringNYC at gmail.com. We're going over the 2017-2018 SHSAT. If you need a copy, please email me at the bottom. I'm GregsTutoringNYC at gmail.com. I specialize in a whole bunch of specialized high school tests and middle school tests and just specialized tests in general. Including the SHSAT, especially including the SHSAT. So we're going over this. I'm at the grade 9 level right now. I covered this example the other day. It's question number 3 on page 143. And my head was killing me. I have chronic pain in my head, so I can't always get through stuff. So I jumped ship on that problem. My head's a lot better today, but I'm going to jump ship. So I do really just want to focus on this problem again today, because I want to show alternate views. And Henry David Thoreau has a quote, it's not what you look at that matters, it's what you see. And this is kind of where you need to go with some of these problems. There's the classic solutions, and they work, but they don't always leap out at you. And as you know, if you're following me, and by the way, please like this video, please subscribe to my channel. If you're following me, you know I'm big on trying to provide alternate solutions to a lot of these things. And this one involves more visual aspects to it. So we created the scenario. Oh, let me get this off the screen. We created the scenario the last time. Let me see if I just do that. Should that go away? Yes. We created the scenario the last time, whereas we ended up we had 2 ways to get the height here of this right here. I'm going to use colors today because it's significant. And this was 3, and this length was 4. We could have also got it based on the coordinates of these 2, because this is 5, 1, right? And this is 2, 5. So we can get the 5 minus 2 and get the 3, and the 5 minus 1 and get the 4. We're not worried right now whether it's negative or positive, okay? And we can get the height, and if we read the problem, it says that this was shifted over 1, so this became m prime, and this got shifted over 1, and this became n prime, okay? And if we draw a line, and I want to draw it as straight as possible this time because I want to show something specifically at some point. So give me 1 second. I'm lining this up. And they want to know what the area of this right here is. Okay, and here, let me fold this paper so we can get that solution going. So the length of this here was 1, which means this was 1 as well. Okay, and the height was 4. So we ended up getting the base times the height. Okay, the base is length 1 here, and the height was 4, and that's equal to 4. And we talked about how it wasn't 1 times 5, because if you realize this is 3 and this is 4, you also realize that that length is 5. It's a 3, 4, 5 triangle. We'd also use the Pythagorean theorem. Once we know this is 3 and 4, we can get 3 squared plus 4 squared equals c squared. And we get 9 plus 16 equals c squared. And we get 25 equals c squared. And then we take the square root of both sides, and we get 5 equals c. All right? So we know that that length is 5. And if this is 5 and 1, and this looks like length times width, and it's not. Okay? So we went through that, and I'm just representing this just to get it kind of tidy. So it turns out there's a couple more solutions to this. And it kind of proves that it is that it's 4. Another way to do this is if we drop down from m prime over here and come along like this. Okay? We already know the length of this is 4. the length of this was 3. But from here to here, this is also 4. Okay? So that means this whole square, the area of the square is 16. Okay? But we have 2 triangles. Triangle A right here and triangle B right here. All right? And A is the area of a triangle is 1/2 BH. So the base of the triangle is the 3 and the 4. So we get 12, right? And half of that becomes 6. Well, both of these are 6. So we get 16 minus 6 minus 6. So we get 16 minus 12, and we get 4. You see how I did that? So we figured out the length of this was 3 or 4, and that was 5, which means this is 4, this is also 3, and this is also 5. What I did was took the area of the whole thing, I removed triangle A, I removed triangle B, and all we were left with is the green shaded area. Right? So if we go back to the thing about what you're seeing versus what's there, and this is also, there's other quotes like, don't get lost in the forest for the trees, or all these kind of quotes like that. If you orient and train yourself to look at these problems in this way, and you're not gaming the system, because this is learning how to deal with spatial math. Okay, we did it over here as in raw math, and parts of this here too. We're trying to talk about how to deal with it spatially. Okay? All right, so that now we have one where we just compute the base times the height of the parallelogram inside of there. That was the first choice, right? Not the length times the width, the base times the height. In this case, our base was 1. It's easy to think we're looking at it this way. We're not. By the way, I'm going to mention this again. While you're taking a test, you're allowed to twist your paper around. You can turn it upside down. There's some cases where you may even want to hold it up to the light. Although that gets testy, so be careful if you go that mile, because they might say you're cheating, but what you're trying to do is look through the paper, and because sometimes they want to do reflections and so on, especially in the grade 9, and you want to be able to visualize that. There's formulas to do that. You can visualize it topologically in your head. You can also visualize it physically by doing stuff with the paper. So there's ways to do that. But in the worst case, you can quietly turn your paper around to different orientations. But if we go like this, it's clear that the green shaded area is a parallelogram. Now, the reason the base times the height thing doesn't work is because squares and rectangles are also parallelograms. And in their case, since there's 90-degree angles, the height is the same as the one side. In this case, the height is not, because we don't have a 90-degree angle, and we get that 4. Right? You got that? So if this was a rectangle, it would go up that whole column. There would be nothing there, so it would be 1 by 4. But in this case, that wasn't the case. So we can't really go there. So now we have 2 ways. We have the base times the height way. We have the 2 triangle way. It turns out there's a third physical way. And I actually should have printed a second copy out of this. But let's imagine that we take triangle A and we shift it over 1. And I'm going to use blue for this now. So this is getting busy. So we have this here, this here, and this here. Okay? So what we did was we took the green triangle and shifted it over 1 that way. And there's a funny thing that happens. It leaves this hole here when we do that. And the funny thing about this hole is I just described that hole. That it was a rectangle with an area of 4, because it's 1 by 4. So look what we did. We shifted it over, which gave us this thing here, the green area. But at the same time, we opened up a gap So the blue one is actually, the green one gets shifted over and becomes the blue one. And we're left with the hole. So we can just say this is transparent. And we have this area here, which is 4. So if the hole is 4, then that's the same size of this here. All right? And some of this is just a simple example. This is one simple geometric example showing that if we look into it deeper, we can get kind of different things going on. Now, there's another way to do this though, but it's kind of sloppy. So I'm going to mention it almost just in passing, but let's see how much we can beat it up. So here's the deal. Is there a space on here to do that? Yeah, let's try to use this upper corner here. So ignore everything we've done so far. So if we're over here, let's say we had 3 going down 4, 1, 2, 3, 4. And we had this here. It turns out when we do this, it creates the same kind of scenario there. All right, so this is 1, this was the 5, this is the 3, this is the 4. Okay, and if you drop this down at a 90-degree angle here, okay, and we call this triangle, the little triangle in here, the little one I'm blackening in now, let's just call that T. It turns out there's another little triangle over here that's not there. So the argument is, how about we take this triangle and put it over here, and now we have a rectangle. See, now this is the death of everybody, and I'm mentioning this for 2 reasons. One is some kids can visualize that, and then they're going to say, oh, it's 5, and this is 1. And the problem is this right here, from here to here, they're going to say that's 1. The problem is it's not 1. The hypotenuse is 1, right? This was a right angle inside of there. The hypotenuse is 1. Because it's easy for a kid to see 1 here and go, oh, 1, 1 square root of 2. Or something's 45-degree angles in there and stuff like that. But that isn't the case. It's teeny enough to look like it's the case. And you're thinking, oh, 90-degree angle, 1, 1 square root of 2. Without thinking about it. So you're just going to assume that's 1. And it turns out it's not 1. So really what we have is, we have a triangle here that's not 45-degree angles. This is 1. The question is, this is length x, and this is length y. What is x and y? Or in our case, what is y? Because if it's 1, we get 1 times 5 and we get 5. Which is answer C. The question is it greater than 1? Is it less than 1? So it turns out there's a few combinations of things here. So there's a little kind of insight we can do here, which is if we make this 1.0, does anything leap out at anybody? Right? And if we drew this straight, we know that x is less than y. What leaps out is we have a 3, 4, 5 triangle. 5 times 2 is 10. So that would mean this was 0.5, this was 0.4, and this is 0.3. So it's 0.3, 0.4, 0.5. And if we double it, then we get 0.6, 0.8, and 1.0. So it turns out this length is actually 0.8 if we need to calculate it that way. Now we're not guaranteed that it's actually 0.8. But if we do 5 times 0.8, we get 4.0. So we kind of have a sloppy way to double check that all this makes sense. And this one is really, really going deep into the bowels of this thing. And I'm not even convinced it's mathematically accurate. But it's just to prove that this was not 1. And we kind of use the answers to force feed it back. Like what could be going on here, right? Because if the hypotenuse, this is the right angle here. If the hypotenuse is 1, then x and y, not only is x less than y, but x is less than 1 and y is also less than 1. All that becomes true there. So the only kind of conclusion you can reach is that it was a 3, 4, 5 right triangle. So don't get led astray when you just see something like 1, because just adding that 0.0 in there kind of gets your brain to go, whoop, oh yeah, you know, that kind of a thing. All right? And there's probably ways to prove what these angles are here. I haven't thought about it deep enough to do that. So anyway, we have the BH way, right? We have take the whole area of the whole square, subtract the two triangles, get the middle. We also have get one of the squares. By the way, we could have taken the bottom and shifted that left. But anyway, we took the green square and shifted it over to the right square and figured out the whole. And then we did this way. All right? So we kind of really beat this example to death. And it's really cool the way math works. And, you know, this is nice stuff. So if we bring this back, you know, it's not what you look at that matters. It's what you see. So it's your job, guys, to look at these problems and just spend another second longer on it. And you don't want to do that really on the test. You want to do that now beforehand so that you're used to solving spatial and topologically oriented problems. Now, initially, this problem probably didn't look like it was that way. But it turns out that those are solutions. So you need to have that in your math toolkit, and your geometric toolkit, and your grade 9 toolkit, and your SHSAT grade 9 toolkit. All of this combined together to really add up to be what that is. All right, so I hope this was helpful, everybody. Please like, please subscribe. I got tons more videos. I'll continue the other grade 9 sections of this test. We already did a few more other questions of this. And hopefully everybody has a great Sunday and that this makes sense. Guys, please email me for any reasons whatsoever. I'm here to help you guys. And if you need tutoring, don't hesitate at all. In fact, that's why I'm cutting this short. I have some sessions going on for later today. I will probably set up some Q&A sessions, but I can answer those through my phone when I'm on the train and just walking down the street and so on or whatever. So I don't need to have my computer just sitting there dedicated with me sitting in front of it. All right, guys, and you know, as usual, I check that either it's in front of me in a tab that's visual to me, or in my phone. Like I say, I can have my phone or a tablet on the side, just running this stuff, and it just pops up, so that I don't have to sit here dedicated watching it. So if I don't respond to that in 5 or 10 minutes, just hop back on that same stream later on. Some of them I delete, some of them I keep hanging around if the questions are good. So, you know, just chill out. And if you want to replay a AMA stream, what you need to do is go move the thing from top chat to all chat, live chat or something like that, and it'll show all the messages. And then just move the timeline scrub button to like 20 seconds before the end of the stream, and all the messages will pop up at that point, as you know, minus the last 20 seconds worth. So, all right, people, have a great weekend. SHSAT's coming. Woo! Peace out.